In this video, we are going to look at factoring by grouping. So we will be factoring quadratic expressions that include 4 terms. Okay, factoring quadratic expressions that have 4 terms. So look at the first example. In later courses, you will learn that you can also use this technique when you have 6 terms, 8 terms, 10 terms, even number of terms. But for now, we're only going to look at the one for intermediate algebra level expressions that have 4 terms. So here we have 1, 2, 3, 4 terms. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Sometimes you have to rearrange the terms. Usually it works out fine without rearranging the terms. Okay, so let's go ahead and try the first one. As you see, the name says grouping. So we're going to group the first 2 terms together and the last 2 terms together. Okay, so figure out the GCF between the first 2 terms. What's the GCF between the first 2 terms? Looks like between the first 2 terms, I have x squared as a common factor. If I pull it out from the first 2 terms, x squared times x will give me x to the third plus 4. From the next 2 terms, what is the greatest common factor? It's a positive 3. And then I have x plus 4. At this point, these 2 parentheses are matching. If they're matching, that means you're going in the right direction. If these 2 parentheses do not match, 2 things possible. Either you messed up, made a mistake, you need to go back, check your work, or your polynomial is prime, it's not factorable. Okay, so x squared plus 3 times x plus 4, because x plus 4 is the GCF, I can pull it out all the way in the front, and I'm left with x plus 3 in the second parentheses. And you can write them in any order, it doesn't really matter. Let's check out example number 2. Group the first 2 terms and the last 2 terms. Is there any common factor in the first 2 terms? Yes, looks like a 6 is a common factor. In the last 2 terms, the common factor is a positive y. Do not forget the sign. This is a common mistake. A lot of students forget this sign, and the next step they're confused. So if it's positive y coming out, negative y coming out, we must bring the sign with it. X minus 7. Now we can see a common factor. There's my GCF. I'm going to pull out x minus 7 all the way in the front, and I'm left with 6 from the first portion of my polynomial and plus y from the second part. Okay, so x minus 7 times 6 plus y. And if you FOIL these, you will get this back if you multiply them together. Next, we have 12x squared y minus 42x squared minus 4y plus 14. Let's see what's the common factor between the first 2. Group the first 2 terms together and group the last 2 terms together. That would be 6x squared, and that's 2y minus 7. The last 2 terms looks like I can pull out a negative 2 and 2y minus 7. Y minus 7 because if I distribute this negative 2 back, I will get my plus sign back. Okay, so be careful because I pulled out a negative 2. Inside my parentheses, I have 2y minus 7 now, because when I multiply them back, I should be able to get the polynomial that I started with. Now again, these 2 parentheses are matching, so that's my greatest common factor. I am going to pull that out. I am left with 6x squared minus 2 in the second parentheses, and that's my factored form of this polynomial. Let's look at example number 4. For example number 4, what am I left with? Let's check. Is there any common factor between 3x plus 4? 3xy minus 4? No. How about x minus 12y? No common factor. So I'm going to try to rearrange a little. That way I do have some common factors in the terms. And addition is commutative, so you can change the order of the numbers. It does not really make any difference. Let us go ahead and find out what is the GCF in the first 2 terms. Looks like I can pull out 3y plus 1. And the next one, I can pull out a negative 4. And that's 1 plus 3y. Why am I changing this negative into positive? Because when I distribute the negative sign, I will get my negative back in there. Okay, so be careful because I pulled out a negative 4. That's why I'm changing it to a plus 3y. Now 3y plus 1, 1 plus 3y is exactly same thing because addition is commutative. So that means I can pull out 3y plus 1 and then I will have x minus 4 in the second parentheses, and that's my factored form in here. Number 5, pause for a minute, go ahead and give it a try and see if you can handle it without much help, and then come back and check. Is there any common factor between the first two terms? Looks like I have 15 as a common factor. That leaves me with 6 plus y squared. In the next two terms, I can pull out a negative 3x. That looks like a common factor. Negative 3x times what gives me a negative 18x? Well, that's going to be 6. And plus here, because when you distribute, you'll get your negative back, y squared. So 6 plus y squared, exactly same thing in these two parentheses. That means I'm able to pull that out as a GCF. And in the next parentheses, I'm left with 15 minus 3x. And that's all in the factoring by grouping.